Hello, let's continue our Sudoku adventure with Space-Time Phone Box by rockratzero. Now, this is obviously a reference to the TARDIS, and Rockrat wanted themselves to be blue, but we were using blue for minimum cells, not maximum cells, so I I forced it to be red. I apologize, it is a red TARDIS, but I feel like consistency of constraint coloring is more important than the theme. But anyway, this is part of our Fortress theme week. So we have our maximum cells here, and then we also have crop key pairs. So let's go over the rules. So we have normal 6x6 Sudoku rules, which means in every row, every column, and every 2x3 box, we are placing the digits 1 to 6, exactly once each. We also have these maximum cells in the grid, these maximum fortress cells. The way these work is they have to be bigger than all the adjacent cells that aren't also maximum cells. So you can see that we have symbols. We have these greater than signs adjacent to the cells. We have which have to be less than it, right? This has to be bigger than the adjacent cells that are not also maximum cells. Obviously, this can't be bigger than this and this bigger than this. So when they're adjacent, they cancel each other out. That's part of the rule set. But this one has to be smaller than this one. So if this was, say, a 4, then this cell needs to be smaller than 4. So it could be, say, a 2. This one could be a 3. And this one could be also smaller than 4. This could also be a 2 because it doesn't have to be bigger than this one. There's no symbol there. All right, and we also have crop key pairs. So we have white dots and black dots. So digits separated by a white dot are consecutive, meaning if this is a 2, this could be 1, because 1 is consecutive with 2, or this could be 3, because 3 is consecutive with 2. And then the black dots separate digits that have a 1 to 2 ratio, meaning one is exactly double the other. So if this is a 4, this could be a 2, because 4 is double 2. Or we could go the other way around. We could do 4, 2 this way. The order doesn't matter. What matters is that one of them is double the other. Now, I could have a 2, 4 here. There's no black dot. That's fine. I could have a 2, 3 here. There's no white dot. That's fine. There's no negative constraint. There could have been more dots in this puzzle, maybe. But yeah, we only get positive information about where the dots are. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, how shall we get started? This is interesting to me that we have 2 white dots and then these cells. I mean, this is bigger than that, which doesn't do a whole lot, does it? Well, we need a 1 somewhere in this row, and we can't put 1s into maximum cells because 1 isn't bigger than anything. So one of these is a 1, 2. I don't even know which one would be 1, 2, though. Let's see, what else can we do here? This, I mean, these don't see each other, so this could be a 2 with a double 1 here. This cell here can't be a 1 or a 6. This is from 2, 3, 4, 5. I'm stretching a little bit here, but you can't put a 5 on a black dot because nothing. You can't double 5 to 10, and you can't half 5 to 2.5. Apologize about my phone there. Forgot to silence it. All right, so we could be from 1, 2, 3, 6, but no 5, which is really not that helpful. What's the break into this puzzle? We can't put 1s in any of these cells. That's probably important, right? Because we need a 1 in this column, we need a 1 in this column. So the 1's going to go up here, and the 1's going to go up here. So that means this can't have a 1 on it. Oh, sorry, I missed 4 when I penciled this. I don't know how that happened. Does that help me? How much does that help me? These also can't be 6. We can't put 6 in any of these cells. Is that helpful? Yes, I need a 6 in this column. We can't put a 6 in any of these cells because they would not be less than these ones. And so the 6 has to go up here, which means it goes with a 3. So this is a 3, 6 pair. Okay. Now we know one of these is 1, 2. Still not sure what to do with that. But this 3, 6 pair, how does that help? Now we need a 6 here as well. There we go. right? So it's but this can't be the 6 because these can't both be 5. So this is the 6, this is 5, this is 4, this is 1, this is 1, this is 3, this is 6. Wow, a bunch of digits right away. Okay. Just had to think about it, right? This, we need 2 and 3 in this row. This can't be the 3. So this is 2, this is 3. This, we get a doot. Nice. This is a 2. And then these are from 4, 5. Now, this could be 5, 6. It could be 5, 4. It could be 4, 5. It could be 4, 3. So that's not super helpful. This 2 can't go with 3, so it has to go with 1. So now this isn't the 1, 2. So now this is the 1, 2, and we know the order. So now this is bigger than 2. So this is from 3, 4, 5, 6. Yes, I am willing to write that. This is at least 3, and this is bigger than it. So this is from 4, 5, 6, and it can't be a 4. Okay, so one of these is a 2, and this can't be a 2 anymore because this can't be a 1, right? The 2 is not in here. It's not there. And this can't be a 2 because this would need to be a 1. So this is the 2, and then these are the same digit. This is from 3, 4, 5, 6 as well. So these can't be 4 because, again, this digit goes in this box somewhere. The roping, if you want to think about it as roping, we have the 1 and 2 already. This digit's the other one. So they're the same digit. This is from 5, 6. Okay, I need a 4 in this row. It goes on this white dot. So there's a 4 here, which is either going to go with a 3 over here, or it's going to go with a 5 over here, which is kind of interesting because of this 3, 5. What about this column? Let's think about it. We need, one of them's going to be a 5, which is going to force a 6 next to it. Anyway, we need a 1. Yeah, we need a 1, 4, and 5. So this is bigger than 4, 5. This is from 5, 6. Curious. I need a 4 over here. I'm trying to think how this works out, but I don't know that I can do anything directly yet. So 1, 4, 5. So 1 can't go with 2, so that's not a 1. So, oops. So we can place the 1 here. These are from 3, 4, 5, 6. Unfortunately, that doesn't restrict things. I'm going to write it anyway. I need a 2. Okay, yeah. I need a 2 in this column. That goes next to the 1. So that's a 2. And then this is from 5, 6. So this has to be the 3. That kind of makes sense how this is working out. This is 4. This is 5. This is 6. This is 3 and 6. You can see these ended up the same. I didn't know these would end up the same, but I suspected. Couldn't prove it. This is 5, which makes that a 4. 4 has to go with 3. That's a 6. 5 and 4 are done. That's 5. We get another DT2. That's a 4. Now we should be able to finish up. So these are from 3, 4, 5. Oops. And wait, what happened? Okay, so this is the 5. This is the 3. This is the 4. And these are from 1, 2, 6. So that's the 2, the 1, and the 6. There we go. Cool puzzle, Rat. I liked this idea not only of forcing the 1s up here, but forcing the 6s here. That was neat. It took a little bit of thinking outside the box, literally. But yeah, using both properties, that you can't put a 1 in a maximum cell and you can't put a 6 next to a maximum cell, was really important to get into this puzzle. Very cool. I enjoyed it. Hope you did too. If you did, then why don't leave a like, subscribe, and a kind comment below.